Ladles and jelly spoons, welcome back to Badgerworks. Today, this. As you can see, it's a bit of a mess in here today, but there is a reason for that, and I'll tell you about it. So let's get on with it. So, Christmas is rapidly approaching. I have been absolutely nuts busy with work and all sorts of things recently, and I'm just trying to catch up with everything and keep on top of everything. What I'm doing at the moment, this is a commission for a venue that I work at. Basically, they have a new show, which I'm not involved with, but it's a magic themed show, not magic like Tommy Cooper kind of magic. It's set in a wizard prison. And one of the characters needs a wand that lights up, and they bought wands and they tried different things and none of it really worked. And I said to them, I was like, why didn't you just ask me? The guy who makes props and specializes in microelectronics. Anyway, so this is what we're doing. So I've been commissioned to build a number of these wands. I've already built one. I built a prototype which they were very happy with, and I've then refined the design, and I'm now assembling the wands, and I thought I would show you what I'm doing, just because why not. So the main criteria for this, because it's a prop, is it needs to be robust, and it needs to last. So this is going to be a bit of a hodgepodge, because I'm basically doing this, I'm telling you this as I'm doing it. So I've got a few bits here. I'll show you the various bits as we're going through. The main star of the show, as it were, is this. Hopefully you can see that. That is an Epistar diode. So it's basically an LED, but it's not a normal LED. This is 3 watts, and it is ridiculously bright, like stupidly bright. If you run this at their full voltage, they are blinding. And that's basically what they want, but I am going to step the voltage down a little bit just to give it longevity. If you run these at full voltage, they are really bright, but they don't last very long. Whereas if you step the voltage down slightly, they're still really bright, but they'll last basically forever. So we'll get onto that later. We have a charging board. You've seen me use these before. This is one of the ones with a USB-C end on it, just because it's a bit more modern. We have a battery here. Now this battery came out of a certain device beginning with V that I won't mention because YouTube will demonetize me, because apparently it's promoting harmful practices to talk about batteries, but there you go. So it's kind of funny, really. A lot of these devices, especially the disposable ones, actually have rechargeable batteries in them. They have no charging circuit, they just have a rechargeable battery, because I suppose it's cheaper than using a normal battery. So what I do is where I work, there's quite a few people who use these things, and I say, instead of throwing them away, I left a bucket basically in the staff room and said, when you're finished with it, put it in the bucket and I'll dispose of it. And so what I do is I dismantle them, and I take the batteries out, and if some of them have charging circuits, I take those and then I break them down into their various, plastic, metal and so on, and I recycle them, because it saves them ending up in landfill. So this is the battery we're going to use. This is a 13300 lithium polymer battery. It's 3.7 volts, 360 milliamp hour. And these are really handy, and I've got loads of these that I can now use for my projects, like this. So there's that. We'd have to desolder all of this in a minute. This is the internals of said wand. So this is where the battery and the charging circuit and everything will go. We have the tip of the wand, just the tip. Stop laughing at the back. So this is going to need to have the light in it, so we'll do that. That will be the first thing we do. And then we have the handle, and that's what this fits inside. So we are going to start by fitting the LED in here. So to do that, I'm going to use a couple of different types of wire for this, simply because, well, I'll explain as I go. Let me cut a couple of bits of wire. Right, so I've cut these wires. These are basically just slightly longer than the one tip. So we'll put that to one side for a minute. And what we're going to do is strip the ends of these. We only need the tiniest little bit of wire exposed. And the other thing that we've got here is this. Now this is a pin setup for a circuit board. So this would normally go like this on a circuit board. Like that, you see. And you would solder it from the underside, and it allows you to plug something onto the circuit board. We're using it for a slightly different purpose. So we're going to use this as our power plug. So what we need to do first of all is solder these wires onto this. So I'll just put that in there. Oh. I apologise for the bench being a bit of a rat's nest, but I've been doing so many different things recently, all at once. It's ridiculous. I've been printing non-stop for weeks, and what didn't help is the printer decided to pack up, so that was fun. I honestly don't know what went wrong with it, but one day it just went, I'm not going to print anything anymore. Nothing's going to stick to the build plate. I have a sneaking suspicion that what happened was one of the teeth jumped a tooth, well, one of the belts rather jumped a tooth on the stepper motor. I had to re-level the bed, and even then it was anyway, that's beside the point. So we've got some solder here and a soldering iron. Don't know what's going on there. Anyway, so I'll just get some solder on here. And this is kind of awkward, but we just put that on there like that. I really should put my glasses on to do this. Right, that goes like that. And this goes I really should put my glasses on to do this. Like that. Right, so that's that. So what we need to do now is we'll get some of this heat shrink. And this is here, this heat shrink is here primarily to, obviously, to protect the soldered end, but it's also to make it easy to see which is the positive and negative side of this. All will become clear once we get a bit further down the line. Right, so that goes over there, and that goes over there, and I will just throw the heat gun on these and seal them up. 1 second. Right, that's that. That's still really hot. Now we will nip the end off the other end, and again we only need the tiniest little bit of wire showing. Now I really do need the glasses because I've got to see the markings on this. So these ones are actually quite handy because I really don't know if you'll be able to see that or not, but on the tab, these are actually designed to be surface mounted. That's why they have these flat tabs. But these are, they actually have a plus and minus like stamped on them, which is really useful. But anyway, so that is our positive. I'll just put that in there. And we'll put some of that on there. Oh, I need to put some heat shrink on it as well. Because if you forget to put this on, you'll hate yourself. because obviously that needs to go on before we solder anything. Get on there. Right, and we'll put a little bit of soldering paste on the wire. And that goes like that. And then the other one goes like this. And I try not to burn my fingers. There we go. Right, and I will just heat shrink these again. Right, there we go. And so what we're going to do now is we're going to bend these tabs down just gently like that. These diodes, by the way, get ridiculously hot. I'll show you how we're going to deal with that in a minute, but on the back here you'll see there's a metal disc. That is actually so that you can mount these on a heat sink to draw some of the heat away from them. But anyway, so that's that. Now you'll have to excuse the somewhat haphazard nature of this wiring on this, but this is a little test rig that I knocked together very, very quickly just to test these with the correct voltage. So we'll just plug that battery in there. And right, you go there. And there we go. So that works. If I actually had more time, which I don't, I would have put this in a little box so that you could literally just plug that in and test it, but I haven't had the chance. That was the whole point of this originally, was to do that, but I didn't have time. Right, so now we need the tip, which I have put down somewhere. Where did I put that? There it is. Right, and so now we run this through here, like that, all the way down to the end. And I need to finagle this into place, but that sticks out the bottom there, you see. Let me get this wedged in and then I'll show you what we're going to do with it next. So that goes in there like that, you see. And like I said, these things get hot. This is 3D printed plastic, which is not very good at taking heat. And so what happens is if you just run this like this, it will basically melt the plastic on the end, or it will get soft, and this just pops out the end, which is not what we want. So what we're going to do, and also we want to hide as much of this white as possible. So in order to get around that, what we're going to do is we are going to take a piece of this heat shrink, cut a suitable bit off. It doesn't need to be very long. That's probably more than enough. Right, kind of like that. And let me heat shrink this and I'll show you what it's doing. Right, and there we go, you see. So by heat shrinking that, it hides the white, and also because this will basically stand a much higher temperature than the plastic, this holds everything together. So yes, that will do exactly what we want. And also, because it's heat shrink, if it does get hot, it will just basically grip tighter. So that's that end. That's that bit done now. So we can put this to one side. I might dress up this end a little bit. It's also worth remembering that the area of the venue this is designed to be used in is very, very low lighting. It's meant to be like a kind of dungeon thing, so it's very dark in there. So this is why we didn't need to go too mad with like detailing and everything. It's just basically to give the illusion of a wand. But even so, it's a lot better than what there was before. Let me show you. Oh, this is funny. Hang on. So this is part of the wand that they got from someone else. It's 3D printed, the same as mine, but look how thin the walls are. This snapped. This is why they couldn't use it anymore, because basically, it's basically just pushed together like that, and it's quite a good fit. But it's basically just a tube with a light in it. And there was some really weird stuff going on with the wiring as well, which I won't get into now. But I would genuinely like to meet the person who made this and just say, what were you doing? Because anyway, we haven't got time to get into that now. As I said, this part is now done. We can turn our attention to the insides. So we need this, and we need our circuit board, and we need our battery. So the first thing I need to do with this battery is pull these rubber bits off. Oh, they stick really well. I'm always worried it's going to tear the tabs off, but it never does. Right, so we need to get these wires off first. Like that. And then the wire off at this end. Like that. And that gives us a nice fresh battery to use, you see. So this has basically only been charged once and then thrown away. It's such a waste. Anyway, so we are now going to swap wires because we need something a bit more flexible. So we're going to use this. This is actually silicon wire, so it's very flexible. And it's also quite thin, as you can see. So what we're going to do is we are going to put a couple of bits on to get everything hooked together. Now, I was an idiot in news that will surprise no one. When I did the first one, I should have measured all the wires so I knew how long to cut them for the other two, and I didn't. So we're going to kind of wing it. So we need to connect the battery to the charging circuit, and we need to connect the charging circuit to a switch and various other bits and pieces. So it will all be in here. So we can use this to give us our rough dimensions. So what we need is a piece to go from the charging board out to the end of the wand, or the end of the handle anyway, which is probably going to be about that much. So we'll cut that off. So that's one bit. And then we need a piece to go from the charging circuit to the battery, which will be about that big. And I'm cutting these slightly longer than they need to be because I can always cut them down afterwards. So that's that. Now we need a positive to go from the charging circuit to the switch, which will be about that much. And then we need a piece to go from the charging circuit to the battery, which will be way less than this. But like I said, better to cut them long and then trim them down afterwards than put it in there and find out that you haven't got enough wire, because that's really annoying. Now, let's get these wires all stripped on one end, and we can solder them onto our charging circuit. Right. If you don't have one of these, by the way, I know I mention this every time, seriously, they are so useful. Right, soldering paste. Now, the other thing I don't want to do is do what I did on the first one and actually solder the wires on backwards, because I was rushing, and, you know, less haste, more speed, you know. Yeah, I soldered the red wires onto the negative side. I had to desolder everything and do it all again. It was just like, you absolute moron. Okay, so let's get some solder. And that is the positive out. That goes like that. This goes to the battery. Don't drop it on the floor. That goes like that. And this goes to the battery negative. Oh. Like that. And this goes out to the light. There we go. That was easy. Right, so for my next trick, I'll just wipe that excess solder paste off of there. Now, what we need to do is get this in here. So we put the wires through like that, and then that goes in there like, go on, get in there. Go on, in you go, there we go. And that goes like that, you see. Might need to trim that hole slightly. I think where I've painted it, I might have put, I might have closed the hole up slightly with paint. Let me just clean that hole out, hang on. Right, there we go, that's more like it. That's that in there. So what we need to do now is connect the battery. So let's just get that out of the way for a second. And we'll cut this wire down. And trim the end of that. Oh. We are now entering redecorating your house through the letterbox phase of the build, that you'll be pleased to hear. So now we need some solder paste on here and some on the wire and all over my fingers, because obviously, right. Okay, and then we solder this like that, and we pop this in here like that, and through and out the other side. There is method in my madness, trust me. Oh, get that out of the way. And now about there. Trim the end of this. And we do the same thing again. That goes on there. Soldering paste. I should stop calling this soldering paste. Someone actually called me out on it in one of the other videos, and they're absolutely right. This is not soldering paste, despite the fact that's what it says on the lid. It's actually flux. Soldering paste is something different. Soldering paste is basically a paste that has little tiny beads of solder in it, and you use it to actually solder things. So you put it on a surface, you put the two pieces together, you heat it up, and the little tiny globules of solder melt and basically create the joint. So this is, although it says soldering paste on the tin, it actually isn't. This is flux. But I will probably keep calling it soldering paste just because I'm so used to it and because I'm old and easily bewildered. Anyway, right, you go there. Oh, that was not what I intended to do. Oh. All right, let's try that again and try and get the wire to actually be in the right place. There we go. Right, that goes like that, that goes like that. There we go. And what I'm going to do is I'm going to attach the battery with some hot glue just to stop it rattling around in there. Although, of course, like a bonehead, I forgot to turn the hot glue gun on, so we'll just wait for that to warm up. Talk about yourselves for a minute. You just have to be careful hot gluing 3D printed parts because obviously the heat can affect the plastic. Right. There we go. We'll probably have to trim that with a knife because it's quite a snug fit inside the handle, but that's all right. So we'll let that glue cool down, and then we'll go on from there. So the next thing we need to do, get some of these stringy bits of the glue off, is we need to have a way of switching this thing on and off. So what I've got here is a little limiting switch. So this is basically, it just works like that. So you'll see these on like 3D printers and stuff like that. It's basically so that you can have it so something will travel along, and when it touches, it closes the switch, you see. And so you can use it to determine where something is. But we're going to use it for lighting this up. Now, this metal arm is too long. So I am going to take a pair of side cutters and nip the end off, which is easier said than done because I don't know what that metal is, but it's really tough. So we just want to get kind of that much off. Right, talk amongst yourselves because... Oh! That does not want to cut. I don't know if it's hardened or what, but it's ridiculously tough. I think it might be sprung steel. Oh, blimey. The other one cut a lot easier than that. I think I've blunted my side cutters. Right, I'm going to have to get my big side cutters. Hang on. I put the big side cutters on it and they cut like paper. But anyway, that's beside the point. Right, so next thing we need to do is attach this to the end of that. So, and don't touch the soldering iron because that's really hot. Idiot. Right, so there are 2 mounting holes in this switch, and we need to get this basically like roughly in the well, not roughly, it needs to be in the middle of this. So I apologize if you can't see very well what I'm doing, but then neither can I. About there. And then we put our we make a couple of marks, and that looks pretty good. So we'll drill these out. Like that. Try not to damage anything. There we go. Right, screws. Oh, well, that's useful. I ordered some new screws because I ran out. And I've literally just unpacked them and they've sent the wrong ones. These are machine screws. They're not... Oh, good grief. Hopefully they'll work. I don't know if they'll grip well enough, but we'll have to see. They haven't got to do a lot, but... Oh, come here. Yeah, these are actually like M2 machine screws. They're not self-tapping screws. Okay, we'll have to open that hole out a little bit, because these will not self-tap. So we may well be requiring a bit of brute force and ignorance here. But then, that's what you're all here for, right? Okay, let's give it a go, see if it works. It'll either work or it won't. Right. Let me just move that soldering iron over a bit before I burn my arm on it, because then I will not be very happy. Where's the hole? Stop laughing at the back. I can't believe they sent the wrong things. Oh, I think it's going. Oh, look at that. Right, don't over tighten it because it'll pull the thread out. That has actually worked. Ha! Just as well, because I bought like 200 of them. Right, let's see if this one will go. Go on, get in there. Right, that is very handy. That worked. Whew. That could have been a disaster. But disaster avoided. Marvellous. Right. So now what we need to do is connect this red wire to the middle pin on the switch, because that is the normally open. So let's get that roughly into place so we know how long the wire needs to be. About there. And we'll just nip that off there. And nip that off there. Pop that round there. Like that. And then oh, come on. trying to wrap this wire around here and it's not cooperating. Right. That goes like that. And we put a bit of solderite. Like that. Wonderful stuff. Looks like it grew there. Right, now for the real fun trick. Because this is where the voltage regulator comes in. Because as I mentioned earlier, if you run these things at too high a voltage, they are very bright, but they also burn out very quickly. And we don't want that. So we are going to use one of these. This is a surface mount device, which is not designed to be soldered by hand. It is designed to be soldered by a machine. But I'm an idiot. And I use these things all the time, and because they're tiny, as you can see. This is one of the great things about modern electronics is the companies that make these things, they make millions, billions of them, and they sell them in bulk to, you know, electronics companies. But they also sell them for pennies to the public. So this is an oh God, what is it? AMS 1117. This is an 800 milliamp hour voltage regulator. So this will drop 5 volts down to 3 volts. So this will just make those LEDs last a lot longer. Now, I have to remind myself of the wiring pattern every time I do these. I literally did one yesterday and I've forgotten already because of course I did. Right, yes, so that is that's the way round I thought it was. Okay, we're all good. Everything's fine. So this end is our input. Now what we need to do in order to make this fit is find my, there they are. I'm going to take this end here and I'm going to bend it very gently like that, and I'm going to bend this one as well and this one as well, but these ones don't need to be bent quite so much. This one needs to bend almost 90 degrees, and the reason for that is because if it's not bent it won't fit, because this, I can't just put it on like that because you can see it won't fit in the handle, so I need to put it on basically sideways. And what I'm also going to do is I'm going to take a pair of side cutters and I'm going to nip the end of this pin off because we don't need it that long. Now, this is where the fun really starts, because what we need to do now is put this in here like that. And then we need to solder that onto there. I've got this, I need to get that right on the end. There we go. And we basically solder that like that, you see. So it's tricky, it's finicky, but it's not that bad. Saying that, I'll probably make a right dog's ear hole of it now, you watch. Right. That goes like that, that goes like that, and solder. And there we go, you see? And that keeps that nice and flat so that it's out of the way. Now the output is in the middle, the ground is on the end. So we need to run a ground to this thing. So what we do is instead of like trying to cut 2 wires and solder them all together, I've actually found that the easiest way to do it is this. I just take a paint pen. This is one of my chrome pens. Basically put this where it needs to be and put a little mark on the wire. I really hope you can see that. And then take our wire stripper, and this is the really tricky bit, is trying to get that in the right place in the jaws. But I can just do that and just very gently strip that wire, and it's not quite in the right place, but it will do. It's good enough for our purposes. You can see I actually missed the well, hopefully you can see it, I missed the paint spot. It's not quite in the right spot, but it's close enough. Right, so that needs to go like that. But before I do that, I need to put a piece of wire on the positive one in the middle, because otherwise it will be impossible to do afterwards. About there. Because this is our positive out. So we have 3 volts going in, 5 volts going in and 3 volts coming out. So we'll just put soldering paste all over this in a big blob, because why not? Get that out of the way for a second. And then we need to solder this on here, like that. Oh no, that did not stick. Like that, there we go. And then we get the negative in. Oh, I need to just try and, there we go, that's it, like that. I've got to hold that. Do you know what? I just realised that leg actually has a little negative thing stamped on it. That's really clever. Right, now I need to try and hold that in place while I solder it. That's got it. It's not the neatest joint in the world, but it will do. Right, and now that and that should go like that. And we want these 2 ends to be the same length. I'm just thinking they might actually be a bit long. Might cut those down a bit, we'll see. Because basically what's going to happen is that will sit inside the handle like that, and these wires will come to the end so that we can plug it in, but we don't want too much, because any excess we've got to get back in there when we put the end on, and there's not a lot of space in there. So I might just cut these down a little bit. Let's have a look at this. I think probably about there will do us. Now you might say you shouldn't cut those wires together like that, they'll short out. We've got a switch. Right, so now this is where things get even more interesting, because we are about to butcher some connectors. So you remember the pins we put on there? Obviously we need something put on the other end. So these are pin connectors for circuit boards. Now these are crimp connectors, and there is a special tool for crimping these, and I do have one, but I've never been able to get it to work right. So instead, we're going to cheat and we're going to solder it. Oh, get in there. Which is not really what you're supposed to do, but I also find it just makes everything hold together a lot better. So we put a bit of soldering paste in there, a bit on the wire. And we pop that into, that is got a stringy bit sticking out. Go away, stringy bit. We pop that in there like that, and it missed completely because of course it did. There we go. Right, and then we'll do the other one. Soldering paste. Solder. I couldn't remember what I was doing. Oh, it's been a very long couple of weeks, trust me. Right. And then we put that in there like that and solder. There we go. Right, I'll just crimp these ends. Oh. I mean, technically they don't really need to be crimped, but I think it just looks neater. Not that anyone's ever going to see inside it except me, but that's not the point. Right, that. And but yeah, I'll say if any of you have ever used these things, they do have a tendency, if you don't make sure they're very, very well secured, they just fall off. And I don't really want to be mucking about with that, so I find the easiest way with little things like this is just solder it. I know it's not really right, but that's what it is. Now, oh, not that box. Where is the other box? There it is. Right, this is a little 2-pole, basically holder for these, for want of a better term. It does have a little arrow on one side, so that's where the positive goes. It doesn't matter really, but you know, do things properly where you can. So they go like that, that goes like that, and now we test it all and find out that it doesn't work. Where's the end? There it is. So now if we plug that into there and we click our switch, we should get, there is light, but I think this battery's flat. I don't have a cable to plug into it because it's plugged into the camera. Let me charge this up for a minute. In fact, I'll tell you what, there's one more bit we need to do with this, just a bit of tidying up before we put it all together. Yeah, so as I was saying, there's one more bit we can do with this, just as a little quality of life thing. We obviously have charging status lights there, and you can't see them inside there because of course you can't, they're inside. So what we're going to do is we're going to bring those lights to the outside. So I'm going to drill a hole through the front of this very carefully, about there. And I say very carefully, I'm probably now going to stick this straight in my finger. Right, like that. This is a 1mm drill bit. And what we've got here is a little piece of 1mm fibre optic strand. And we're going to pop that through there, like that. And we're going to put it right next to that LED, like that. I don't know if you can see that, hopefully you can. And now we're going to hot glue everything madly. So what we do is we start by a nice blob of hot glue. Come on. My hot gluing isn't hot gluing. Nice blob of hot glue on there. That is, why is this doing this? My hot glue gun has now decided to play up, because of course it has. Right, talk amongst yourselves for a minute, folks. I'm gonna have to go and steal my daughter's hot glue gun. Right. Oh. My daughters are here. Hello, Katie.
Hello, Katie.
Katie's just arrived to save the day by lending me the hot glue gun that I bought her.
Lending you. You can have a choice.
Well, no, I didn't give you a choice. Well, I need to get this done, all right? And you have a glue gun, and mine now apparently I don't. I'll have to get another one. Yeah, I don't know what's happened there, but it's you can see all the glue has decided to come out the back.
Yeah.
So I don't know. I mean, this glue gun honestly is ancient. What?
The glue gun.
Are you going to make it into something?
Yeah.
Well, yeah, you might as well. I need to turn the thing off and let it cool down, because it's... You'll probably find, actually, if I just gave it a good clean out, it would probably be all right. But the way things are at the moment, I don't have time for that. How do you know when that's ready?
You pick it up and you squeeze it, and if it comes out easily, it's ready.
Oh. So, yes, this is the glue gun I bought for her. Ryobi, not a sponsor, but if anyone from Ryobi is watching, this is quite a handy little gun, actually. So it has a base that it sits in, and what it does is it has a heating element in here, and so you plug it in. There's no battery here. There's no on-off switch. You just literally plug this into the base and it heats up, and then you get like 5-10 minutes use out of it, and then it cools down, and then you plug it back into the base and it warms up again. But it makes it very small and light and handy for a cordless glue gun. Now, let's see if this actually works. Where are my glasses? Right, so as I was saying, we are going to put a nice blob of glue over that, both the LEDs and the end of the fibre optic, like that, you see. And then we're also going to squeeze some hot glue in under there, which is why I left that little channel there, you see. And we'll do the same on this side, like that. And then we're gonna basically put a little blob here and there just to protect all of the electrics. Like that. And we'll pop that in there, and we'll put a little bit there. This is really nice, this glue gun. I might have to keep this.
What?
You don't need it.
Yeah, I do. I need it for gluing my L's together.
She does use it for glue. She uses this. Do you know what? This has certainly had its money's worth out of it. It's you wouldn't believe how much hot glue she goes through.
Yeah.
Right. There we go. That should do us. We'll let that cool down for a minute. But yeah, I don't know if I can get this under the camera. This is the base for this thing, and you literally, when you're done, you just pop that back in and it starts heating up again. The one downside to this is it doesn't have a status thing on it. So this shows you that it's getting power, but it doesn't like go out when it's hot. It's like she said, you have to just press it until glue comes out. But you know, and then it's got an on-off switch there, so you can actually turn it off. Yeah, it's quite a good bit of kit, and it's got, at the moment, it's got a 5 amp hour battery in it. So Right, I'll turn that off from now. I think we're all right for glue for now. Yeah. So let me get this thing tidied up a bit, and then we'll put it all together. Oh, stringy bits. That's the trouble with hot glue, is endless stringy bits.
The inside of a runner bean.
I might put some glue on there as well, actually. Just to protect those wires.
You're not showing the camera.
What? Oh yeah, I'm just putting some in here as well, just to keep these wires protected. Just it stops them getting like shocked loose, if that makes sense. Right. Because I can guarantee you, there's one thing I can tell you from bitter experience, that you give actors something and they'll rattle it and bang it and smack it around. No matter how much you tell them to be careful with it, they'll go, okay, and then throw it across the room. Because, you know, anyway. Yeah, let me trim up some of these fluffy bits. Try not to cut my fingers.
Don't cut towards your thumb.
Cut towards your chum, not towards your thumb. Stop giving my own advice back to me, child, all right?
Oh, you know, remember when you said about
This blade has had it. Go on, carry on. I'm listening.
when you said about because I had my geography test today, my last trial exam.
Bear in mind, yes, when she says test, this is her GCSE mock exam, so it's quite important. Go on.
And we were doing, the test was geography, and it was paper 3, UK challenges and field work.
Okay.
So the first bit was about where we went, which was Cheshire Beach, and Swanage.
Oh, yeah.
And then the next bit was about just like the UK environment and environmental friendliness and stuff. And I wrote a bit, because we have to do a 12 marker essay about I wrote 3 pages.
Good.
About
Stuff.
yeah. Well, the question was, here's this view which was like, oh, sustainable transport is the best option for improving the UK's sustainability and stuff.
Yeah.
Discuss this. So I wrote about all the cycle paths and things,
Yeah.
and then I started going on about the insulation of the buildings, and how you should put and how when you put the gaps in the buildings, it makes them lose less heat. Because I remembered you said something about that.
Yes, that's right. Air is a very good insulator.
Yeah. Because it's a poor conductor of heat.
Exactly. This
Yeah,
is what
that's
cavity
what I
walls.
wrote.
Cavity walls.
Yeah, that's what I was writing about.
Good.
That
Well
was
done.
like-
So you actually
yeah.
listened. See?
Yeah.
Funnily enough, the old man knows what he's talking about sometimes. Oh God. Right.
But yeah.
Now we need to charge this battery up, because we need to make sure this thing actually works. It'd be so funny if I put all this together and turn out the battery's duff. Right. There's a USB-C. Come here, you.
Rip it out of that.
It's plugged into the back of the Bluetooth speaker, but it's fine. It will do for our nefarious purposes. Right, so if we plug that in there, then, oh dear, I don't know if you can see that light. What we do now we've got that glued in place, we take our clippers and we just snip that off flush with the front there, and we save that bit because we can use it for the next one. And there you can see, hopefully, that little red light there.
Little light.
So now that's plugged in, let's plug this back in and see if we actually get any light out of it. Because if we don't, I shall be deeply annoyed, because it means I'm going to have to do all this again. Right, switch. Oh yeah, there you go. So that's that. So it was just the battery was flat. So we can now put all this together. So let's just pull that out of there for a minute. Right.
Why is there like
What?
that and that? It's like muddy.
What?
Muddy, gross, gunkiness.
What, this?
And the other bit.
What? Well, that's flux. What's this?
Yeah.
That's the
what's
soldering iron.
What's the bit underneath it?
Oh, that's a sponge.
Oh.
That's for you, so you can basically, like, when the end's like that, you just, and it cleans the end up, you see. But that's soldering flux. It's called that. This tin says it's soldering paste. We actually had this conversation earlier. This is not. See, this says soldering paste, but it's not soldering paste. I got called out on that a while ago. Soldering paste is it's similar to that, but it has tiny little beads of solder in it. And what you do is when you're doing like surface mount devices and things like that on a circuit board, I'll try and explain this. So on the circuit board, you'll have like a little flat pad of metal where you want the device to attach to.
Yeah.
So you smear the soldering paste basically all over it.
Yeah.
You put the device in place,
Yeah.
and then you heat it up.
Yeah.
And what will happen is when the solder melts, it will basically be attracted to the metal. So it will kind of flow into the metal and then set and create the joint. So that's what soldering paste is. This is soldering flux. Now, soldering paste is basically beads of solder in flux. Now, the flux has various properties, but basically what it does is it cleans the contacts of any grease or dirt or anything like that, and it also helps the solder flow into the joint. So it's used for any kind of soldering, even, you know, like plumbers and that, we use soldering flux. Now, most solders like this actually have flux inside them. It's like, this is why when you do this, you see that smoke? That's the flux. But it never seems to really work very well. You always need to apply flux separately. But this is just easier to do it because you can just dab it on with a paintbrush. Because there's other fluxes you can get that are like a really thick, it's almost like Vaseline, or like a glue stick, that kind of consistency.
Yeah.
Which is fine for when you're doing big stuff. When you're doing little stuff like this you can just slap it on all over.
Yeah.
And it won't hurt anything because it's not, you know, it's designed for the purpose. Anyway, there you go. Right, let's see if we can get this. What? Oh.
Because you wasted the battery.
Anyway, right now, which I think this is the right one. Now, what we've got to do now is put the switch in. So this is the switch, and this is where it gets really fun, because what I've got to do is get that in that hole there. And this is really where we get to redecorate your house through the letterbox. You would think by now I would be used to this, but I'm not, and I still can't do it. Might have to clean this switch up a bit, actually. It might be a bit sticky. Is that? Oh, hang on a minute. Where are my glasses? Hell, fuck, see what I was doing. I haven't even been having my dinner yet. Oh. There we go. Oh, I'm glad I put that new blade on there. I can actually cut things now. I don't know why I didn't put one on before. Anyway, right. Go in there. Like that. We might need to, because I think that might be a bit stiff. Stop laughing at the back. Yeah, that is way too stiff. Don't lose that. I need a thing.
A thing?
Yes, that's what I said, a thing. Right. Right. I just ran a drill bit through there because obviously where I painted it, it's made it, it's closed the hole up slightly. I think that still needs a bit more trimming off of there actually. One of the joys of 3D printing very high tolerance parts on a very cheap printer is it doesn't always go according to plan.
Tardigrade.
What?
Green tarts.
Yes, it is.
With no legs.
Huh?
I said with no legs.
Yeah, well, you see what happened is I'm printing that for your mother because she is using that. It's going to be a gift for someone. And
You're going to paint it Christmas colours?
nope.
Oh.
That was a rather emphatic no, wasn't it, child? No, basically, so I printed this one. This is what's known, by the way, folks, as a print in place. And it's where you print an object and then you can articulate it. And so this is all articulated and everything. But the problem is, this is one of the problems I have with the printer. You can see there's all these little stringy bits on it. And that is going to take forever to clean up. And it's just going to look rubbish. So I basically made some adjustments to the printer and I printed it again and came up with this, which you will agree looks way, way, way better. But it then, when I took it off the bed, it fell apart.
No.
Its legs fell off. Because the way it works, just so you know, is the joints are these little pins here. So let me find one of the legs. So it prints like that, but it prints the pins in place, hence the term print in place. And then when you take it off the bed, you give it a little twist and it all comes apart and it works like this. The trouble is if you don't get the detail, the level adjustments exactly right, it either won't move at all or it falls apart. So it's a question of controlling the extrusion on the printer and undersizing things and oversizing things, and it's quite complicated. And this one, unfortunately, although the print is much better, it fell apart. So there is another one on the printer right now, which is hopefully going to be better. Now we can save this because you could, for example, just use a bit of super glue and just glue those legs on and it would be fine. They just won't articulate. In fact, that's what I was going to say. Did you want this one? You'll have to glue all its legs on.
Well, you gave me another one like that. I just made a wheelchair for it.
Oh, that's right. I remember that, yeah. Yeah, so she's going to have that one.
Thank you. It should be a caterpillar.
Huh?
It should be a caterpillar.
It could be a tardipillar.
Yeah.
A catigrade. Oh.
A moss pillar.
So, yes, there's basically a tardigrade, a water bear. I think they are functionally immortal, aren't they?
Yes, they can survive basically anywhere, even being shot out of a gun or in the vacuum space.
Yes, have you ever never seen tardigrades? They are the most amazing. They're tiny little things. They're microscopic, but they are basically immortal.
Indestructible.
You can't kill them. They'll survive anything. And then people wonder about if there's life in space. Well, yeah, probably tardigrades. Anyway, we're not talking about tardigrades. Right, I need to put this in here. Now, let's just move that out of the way for a minute. Now, this is where the fun really starts. Because what I've got to do is get that connector through there without it getting caught up and pinched and breaking the wires. And also hope that this all fits in here and I don't have to trim anything. I might have to do a bit of trimming. It wouldn't be the first time. But the most important thing is A, to not let the button fall out, and B, to be able to get this in here and get the wires through. I can't see what I'm doing.
Not for the camera.
Well, the camera won't be able to see in there because I can't bloody see in there. Right, hang on a minute. There's a bit of glue in the way. Well, this is, like I said, this is one of the things. This is the tolerances on this are quite tight because I wanted to make it as small as possible. But I might have made it slightly too small. It could have done with being like 1 millimeter wider. Because the whole width of this thing was designed around the width of this charging circuit. But what we might have to do is go for a bit of brute force and ignorance.
Slice all the wires open.
Well, yeah, not, hopefully. You see what I've done with the other one, which is not ideal, but needs must.
You're not wearing your dust mask. You're not wearing safety glasses.
Shush, child.
You're not wearing gloves.
Don't do as I do as I say. But she is absolutely right. I've got glasses on.
You're not safety glasses.
Good enough government work. Yeah, it's just a question of now, obviously, because I've slathered this in hot glue. It's now a question
My
of...
hot glue gun.
Shut up or I won't let you have it back. I paid for it, therefore it's my hot glue.
Really?
Right, let's try that again. That needs to go in that way up. It would also help if I put it in the right end.
Oh.
What are you doing?
Dropping tight again.
Well, did you want the legs and everything for it?
Well, it's fine.
Ah, there we go. Right, now there's a little locating pin on the end here just to get this in the right spot. And now that should work. So let's just plug this in quickly and try it. That does not seem to be pressing that switch.
Oh, no.
Hang on, because it doesn't help that the battery's flat as well. I think that switch might be a bit sticky. I think that might be the problem, is the switch is sticking. Yeah. So it does work, it's just the switch is a bit sticky. Right, so I'll have to take it apart again and clean that switch out, but just for the purposes of what we're doing, the last thing to do is basically feed all this back into here, and on the underside there are some holes. And what we do is we take some screws, and these are
Tiny.
well, unfortunately they're not tiny enough. These are 2.3 by 10 millimeter screws. No, we don't want 10 millimeter, we want 8 millimeter. These ones. 2.3 by 8 millimeter screws.
Tiny.
They are tiny, but they're not tiny enough because what I really wanted was 2 millimeter, but they didn't have any. And then we pop one of these in here. like that. And that holds that end on. And then we make sure that is fully seated. And we put one of these in here. Like that. And that holds that end on. So yes, I need to do some adjustment on this switch just to make it not stick quite so much. But there we go. That is our wand. So the other one I've made so far is this one. This one is red. And basically what I've done is the buttons are color coded. I have also kind of colored, but I'm thinking I'm going to paint this with the same brass paint that I use for this, because I don't really like the way those tips look. But we'll see how it goes. But yeah, that's quite bright, as you can see. I've got one more to do, which will be a green one, but I'll do that off camera. I just wanted to give you an idea of what I was doing. So there you go. So yes, that is charging. I don't know if you can see that or not. And when it's fully charged, it will turn blue. So there you go. Just a bit of something, bit of Christmas magic, child. I was kind of expecting you to go Christmas.
It's Christmas.
No, the moment's past. It's too late.
Oh. Christmas.
It is nearly Christmas. So yes, there you go. This is as close to Christmas magic as we're getting. But there you go. What?
What do you call a legally parked frog?
I don't know. What do you call an illegally parked frog?
Toad.
Oh God. That's actually pretty good. Well done, child. There you go. That's your Christmas spirit. But yes, hopefully you've all enjoyed that. As ever, I'd like to thank my top tier patrons, Howard, Amy, Chris and Ike Live O, for their continued support, and all of my other patrons who have put up with all kinds of shenanigans from me lately. And of course, all you lovely people at home, your views and comments and everything, very, very much appreciated. But yes, there you go. Hopefully you've all enjoyed this little bit of nonsense. Kind of give you an idea of what I've been up to lately, among other things. So yeah, we'll see you on the next video. Say goodbye, Katie.
Bye, Casey.
See you on the next one, folks. Cheers. Bye.
Christmas.